Hello and welcome. My name is Rashmi Shah. I am your teacher for this entire course and very excited to cover SpringAI straight to the brain fundamentals to expert. This opening slide sets the tone. Our purpose is clarity, retention, and transfer into real-world delivery. You will notice that every lesson leans on simple shapes, flows, and mental models before we name things, because the human brain stores pictures and relationships more reliably than isolated terms. We focus on stable fundamentals that survive library churn and vendor rebrands, so that you keep your bearings when APIs, SDKs, and product names inevitably change. The promise of straight to the brain is not marketing flourish. It is a design constraint. Remove unnecessary cognitive load, avoid jargon before context, and push signal over noise. We will translate enterprise AI patterns, prompting, structured outputs, embeddings, retrieval, agents, tool use, evaluation, into compact models you can redraw from memory. We use contrast, what it is versus what it is not, scale, where this fits in the system, and friction, common failure modes, to deepen understanding. The course is split into carefully ordered segments across 72 modules, so that each concept builds on the previous one, letting you climb from primitives to systems safely. This course accompanies an in-depth companion book, PDF, for reference and revision. The PDF mirrors the lecture flow and adds checklists, selection frameworks, and decision trees you can use on the job. You will also see explicit callouts for DevOps, QA, SRE, and product roles, because great AI systems require shared language across disciplines. We default to vendor-neutral framing first, then highlight provider specifics so you can reason once and reuse across stacks. By the end, you should be able to explain and sketch key flows to a teammate without slides, because the knowledge has been encoded as a compact visual story that your brain can retrieve quickly under pressure. Spring has long been the backbone of production Java services. SpringAI extends that DNA to modern generative and reasoning workflows. Why does this matter? First, it compresses time to first value. You can stand up a working flow, prompting, structured output, embeddings, RAG, tool use, without detouring into bespoke plumbing. Second, it favors maintainability. Idiomatic configuration, profiles, and dependency injection reduce hidden state and make AI features more testable. Third, it shields your code from provider churn by offering stable abstractions that accommodate new models: OpenAI, Anthropic, Mistral, Vertex AI, Bedrock, Grok, local runners, with minimal rewiring. Fourth, it matches how enterprises reason about systems: separate concerns, clean boundaries, contract-based integration, and policies for secrets, safety, and observability. In practice, teams report faster experiments that graduate into production pathways, because the same framework supports both. SpringAI also interacts smoothly with your platform: containers, CI/CD, secret stores, and monitoring pipelines. For QA and DevOps, that means predictable hooks and repeatable environments. For product owners, it means features can move from prototype to production without a rewrite. The result is a path where learning directly compounds into delivery, closing the gap between idea, model, and shipped capability. This course package is deliberately comprehensive, yet compact in how it is delivered to your memory systems. The video curriculum is organized into 72 modules grouped into 8 conceptual arcs, each closing with rapid recall prompts and a one-page visual that you can screenshot and revisit. The companion PDF book mirrors those arcs and provides deep dives, comparisons, and edge case guidance. You will find 1. Prompting blueprints with schema, first thinking for reliable JSON output. 2. End-to-end RAG flow diagrams with attention to ingestion, chunking strategies, indexing, retrieval scoring, and grounding. 3. Tool calling patterns for safe action execution. 4. Agent orchestration mental models that emphasize planning and verifiability. 5. Evaluation and telemetry guidance to prevent regressions. And 6. Provider selection checklists balancing latency, cost, capability, and data policy constraints. Each topic is illustrated with simplified diagrams that collapse complexity into 3 to 5 nodes and 2 to 3 flows, the minimum required to redraw from memory. We also include role-aware notes for DevOps/SRE, hooks for containerization, secrets, retries, and backoff. For QA, deterministic inputs and contract testing for model boundaries. For product owners, capability roadmaps, risk surfaces, and milestone criteria. The aim is not just to watch, but to internalize, so that in your next architecture discussion, you can reason quickly without the deck in front of you. AI systems are multidisciplinary. Reliability, safety, speed, and cost emerge from the collaboration of many roles. This course is crafted to give each role a shared, visual language. Software engineers will see how to thread AI capabilities through familiar Spring idioms, keeping seams testable and behavior explicit. DevOps and SREs will get patterns for resiliency, timeouts, retries, circuit breakers, applied to probabilistic components like LLM calls and vector stores. QA teams will learn to test contracts around prompts, structured outputs, and retrieval quality, anchoring variability with synthetic test fixtures and golden traces. Data and ML engineers will connect model concerns, token budgets, context windows, embeddings quality, to application design choices that impact end-user experience. Product owners will acquire selection frameworks to weigh providers, costs, latency targets, and governance constraints. Architects will get guidance on decomposition, boundaries, and observability that make AI components legible to the wider platform. Most importantly, the material is presented to be unforgettable. Concept first, minimal diagram, quick contrast, applied example. If you have ever felt lost in a maze of terms, this course replaces jargon soup with a small set of mental models that you can reuse everywhere, regardless of vendor or stack. By the end of this course, you will be able to produce value quickly and safely. You will confidently draw the architecture of a SpringAI application, how user input maps to prompts, how schemas enforce structure, how retrieval injects facts, how tools execute actions, and where evaluation and telemetry close the feedback loop. You will know how to design prompts that yield predictable JSON, and how to validate that structure before it touches downstream code. You will understand when embeddings help and when they do not, and how to pick chunk sizes, overlap, and indexing strategies that match your corpus. You will be able to compare models using a discipline of trade-offs, latency budgets, token costs, reasoning strength, and compliance posture, instead of anecdata. You will design guardrails around tool calling and agents, so that actions are auditable and reversible. You will embed evaluation in CI and runtime telemetry, catching regressions early, and making improvements guided by data. Finally, you will plan deployments stepwise: local loop, container, staging with synthetic canaries, and production with progressive exposure. These outcomes are intentionally concrete and testable, skills that transfer across vendors and survive the next wave of hype. To make these outcomes truly stick, you will practice summarizing a feature in 1 diagram and 5 sentences. This ritual forces clarity. You will keep a living decision log that captures options considered, trade-offs, and the reasons for picking one path. When requirements change, this artifact helps you pivot without losing the logic that got you here. You will also create a tiny evaluation harness that runs on each commit, measuring structured output validity, retrieval grounding rate, and latency percentiles, so quality regresses less often. You will learn to translate a product requirement into a measurable contract, inputs, expected structure, and acceptance thresholds. When an incident occurs, you will use your error catalog to triage quickly and recover with confidence. The straight-to-the-brain method is a teaching and systems design approach. We start with pictures, because pictures create anchors. A small graph of boxes and arrows compresses dozens of paragraphs of explanation. We then use contrast, what the idea is not, and constraints, what must be true, to peel away confusion. Before sophisticated prompting, we specify the structure we want, schemas, validators, and postconditions, so the system's boundary with the rest of your application is crisp. For every major idea, we supply a 1-page mental model that you can redraw from memory. Redraws are not busy work, but reinforcement for long-term recall. We interleave micro-quizzes and short pause and sketch moments, because active retrieval strengthens neural paths more than passive watching. We include error catalogs, prompt smells, retrieval pitfalls, evaluation anti-patterns, because memorizing a small set of failure signatures helps you debug faster in the real world. And we present multiple role lenses: engineer, DevOps, QA, product, so your brain builds more connections to the same core idea. More connections equals stronger recall. This is not only a learning method, it is how we design AI systems that remain legible, governable, and upgradable under change. To make the approach even more practical, we pair each concept with a check your instincts exercise that asks you to predict outcomes before seeing them, then reconcile differences. This prediction error cycle is a proven way to deepen learning, because it forces your brain to update models rather than merely collect facts. You will also maintain a compact glossary that maps each diagram element to a sentence of meaning, never more than 1 sentence, so memory stays tight and usable. To get compounding returns, consume the course actively. Follow the module order because each step primes the next. After watching a lesson, pause to redraw the 1-page visual. Your goal is not art, but recall. Keep the PDF open as a second screen for checklists and deeper dives. Apply one small idea on your current project within 24 hours, perhaps defining a JSON schema first, or instrumenting a simple evaluation harness, because action forms memory. When making architecture choices, copy the trade-off tables and log your decision with the pros, cons, assumptions, and measurable success criteria. This creates a knowledge trail your team can reuse. Prefer micro-experiments to large redesigns. Stand up a minimal flow. Instrument latency and cost, and only then scale. Schedule a short weekly review. Resketch 3 diagrams from memory, take a lightning quiz, and scan the update notes for provider changes. This cadence cements fundamentals so the details of any specific vendor become easy to swap without losing understanding. If you lead a team, run a weekly diagram club, where each member redraws one concept and explains it in 1 minute. This practice builds shared intuition, reveals gaps early, and makes planning meetings dramatically faster. Use the companion PDF's checklists as ready-made acceptance criteria for stories and tasks. Capture latency, cost, and correctness baselines at the start. Compare them after each iteration so that improvements are visible and regressions are caught. Treat the course artifacts, visuals, checklists, decision logs, as living documents that evolve with your system. Here is a pragmatic 4-week plan that fits busy schedules while building durable skill. In week 1, you will establish the mental models for AI components and implement the chat client with schema-first prompts that return validated JSON. Sketch the high-level system diagram and keep it visible. In week 2, you will introduce embeddings and retrieval in a controlled way. Choose a small corpus, apply sensible chunking, index it, and measure retrieval quality. Add a lightweight evaluation harness to prevent regressions. Week 3 adds action, tool calling and simple agents with guardrails, plus observability hooks, timers, counters, traces, so the system is measurable. In week 4, you perform provider selection using the trade-off matrices, latency, cost, capability, policy, then containerize and deploy behind a feature flag. Throughout, use the companion PDF's checklists, decision logs, and anti-pattern catalogs. Share your one-page visuals with teammates to create a common map. By the end of the month, you will have shipped a small but production-ready capability, something you can demo and iterate on, backed by fundamentals that will remain stable even as providers and models evolve. That is the straight-to-the-brain path from learning to impact. If timelines stretch, extend each week by 1 sprint while maintaining the order. Momentum matters more than sheer speed, and the compounding habits you practice here will continue to pay dividends long after launch.